This video is for surface area and volume exercise 6D, which focuses on spheres. Okay, now I should specify here, I'm going to give you some new results for the surface area and the volume of a sphere. I'm not actually going to prove the results here, okay? So I'll give you some separate links to look at to hopefully justify them. But the fact is, at the moment, the results that I'm going to give you for the surface area of a sphere and the volume later on, we don't actually have a lot of the maths that we need to prove it at the moment, okay? So when we have that maths available to us, we'll come back and revisit it. But for now, this video is really just going to focus on applying these results in different ways. First one we're going to look at, obviously, surface area of a sphere. And here I've got a sphere of radius r, okay? The surface area of a sphere of radius r is given here. S equals 4 pi r squared. Now, you remember the area of a circle of a sphere, the area of a circle is just pi r squared. So this is actually a really nice result, okay? Because if you look at the sphere over here, if we look at what's called the great circle in here, that is called the great circle, as I said, and the area of that circle is pi r squared. But it turns out the sphere can hold 4 of those as far as its area goes, okay? So, it's not so easy as trying to fit the circles on the sphere. I'm sure you can appreciate if you've ever given a present of a soccer ball or something and you tried to wrap it, you would have had some difficulty in doing that. But yeah, it's quite a nice result, the fact that exactly 4 of the area of the circle will fit on the sphere. Okay, so let's jump into a problem here where we're using this formula. Find the surface area of a sphere with diameter 3 meters. Give your answer A in terms of pi and B correct to 2 decimal places. So I'm going to draw a diagram here first. I'd like to have a diagram of these things. So here's something resembling a sphere. And you'll notice the formula was 4 pi r squared. And because it's in terms of r, I'm going to put in the radius. Okay, the diameter is 3. The radius is going to be 3 over 2 meters. And you'll notice I didn't put 1.5 there. And the reason is, generally speaking, an improper fraction is going to be easier to manipulate. Okay, so let's go ahead and substitute it in. We've got S equals 4 pi times 3 over 2 squared. And working that out, that's 4 pi times 9 over 4. And the 4s will cancel, and we're left with 9 pi. And my units are going to be meters squared. Okay? So that's what it means when it says leave your answer in terms of pi. All right, there it is, in terms of pi. For part B, to calculate it to 2 decimal places, all we need to do is pick up our calculators and figure out what 9 times pi is. Now, if you do that, it's going to work out to be 28.2743, something or other. And when you round that to 2 decimal places, you get 28.27, and your units here are going to be meters squared. All right? So, moving on, example 2. The solid below has a surface area of 27 pi centimeters squared. Find the value of r. All right, now, I've been meaning to give you a problem like this for a while. Some of the questions in the book go down this path, but it's an interesting idea when we're actually told what the surface area is and we need to go back and find some of the dimensions of it, okay? So what you want to do here is start off by saying, well, can we find the entire surface area of this thing in terms of r, okay? So that's our goal. I'll say here, find the surface area in terms of r. Okay, so what I might do, the base here, I might call that S1, and that base is obviously just the circle, right? So that's going to have an area of pi r squared. And the curved surface up the top, the hemisphere, that type shape, we might call that S2. And S2, that's half of a sphere. So that's going to be a half of 4 pi r squared, which will be 2 pi r squared. So the total surface area is going to be S1 plus S2, which is pi r squared plus 2 pi r squared. Now, this is just like algebra, right? These are like terms. Pi r squared plus 2 pi r squared is 3 pi r squared. Okay? So you'll notice up here we said our goal was to find the surface area in terms of r. We've actually done that now. Okay? The fact that I know that the surface area is 3 pi r squared, we're ready to go here. Okay? So 3 pi r squared must equal 27 pi. So in problems like this, you're required to essentially form an equation. 3 pi r squared is equal to 27 pi. And this is just an equation. We want to solve it for r. Okay, so I'm going to divide both sides by pi. Pi will cancel. If I divide both sides by 3, I'm going to get r squared equals 9. And because I know that r is a positive number, r is a length, we're going to take the positive square root since r must be positive, and that means that r is going to equal 3 centimeters. Okay, so again, just problems like this, you want to find the surface area or volume or whatever it is in terms of the pronumeral you're given, and then you've got to do something like this where you're forming an equation and then solve that equation to figure out r, or whatever it happens to be that you're looking for. Let's move on to volume of a sphere now. And I've got the result here. The volume of a sphere is 4/3 pi r cubed. Okay, 4/3 pi r cubed. And just very quickly, I'm going to write out the formula for surface area again. It's 4 pi r squared. You can imagine a lot of people will get these confused. Okay, they'll want volume, so they should be using this formula, but they'll accidentally use this formula or vice versa. So just one way to think about it, think about volume. The units for volume are going to be centimeters cubed, meters cubed, something like that. So we're using the formula with a cubed in it. Okay, for surface area, again, the units are going to be, millimeters squared, centimeters squared, something like that. So we're using the formula that's got a squared in it. Okay, so you really need to be on top of those formulas, and that's maybe one little trick that might help you remember which one to use. Of course, that assumes you can actually remember what the formulas are, right? So let's do an example. Find the volume of a sphere with diameter 3 meters. Give your answer corrected 2 decimal places. This is actually the same sphere that we looked at earlier, okay? So here's some type of sphere. Again, the radius, well, the diameter was 3, so my radius is 3 on 2. I'm going to leave it as 3 on 2 because improper fractions are easier to deal with, okay? So I've got V is 4/3 pi r cubed. And if I substitute in, that's 4/3 times pi times 3/2 cubed. Now, you're well within your right here to just pick up a calculator and type this in because it did actually ask for 2 decimal places, right? But I'm going to bash through this anyway. Now I'm going to write that as 3 cubed over 2 cubed times pi. Little trick, if you're not feeling the indices, but the question asks in terms of pi, you can actually just pick up your calculator and type in this bit. Okay, that's going to give you some number, and you know that you just need a pi as well. Okay, but I don't need to do that. I'm feeling the indices here, so let's work through it. I'll cancel out a 3, leaving 3 squared on the top. I might recognize that 4 is the same as 2 squared, so I'm going to cancel 2 squared with the 2 cubed, leaving 2 to the 1 down the bottom. So when the dust settles on that, I've got 9 over 2 pi, and another way of writing that is 9 pi over 2. Okay, now if you pick up your calculator and type in 9 times pi divided by 2, that's going to work out to be about 14.1371, something or other. which will, what do we want? 2 decimal places, so that's going to be 14.14, and we've got volume here, and we're in meters, so that's meters cubed. Okay, so I've got one more example here, and it's a bit of a beast. All right, there's a lot going on here. There's quite a few different results that you'll need. You'll see for the solid below, I'm going to get you to find the volume and the surface area. Okay, so the reason being, I want to put all of this together, everything that we've done so far in this topic, and make sure we're going to be pulling on a bunch of different results to work out how to get this thing. So starting off with the volume, let's stare at this solid for a little bit, and we'll recognize, well, we've got some type of composite solid with a hemispherical component, a cylindrical component, and a conical component. Okay, so a good way to do this would be to split it up. For the volume, I'm going to call this V1 for the hemispherical part, V2 for the cylindrical part, V3 for the conical part. We'll work each of those out separately and we'll add them together. Okay, so first of all, for V1, that is half of a sphere, so that's a half of 4/3 pi r cubed. Okay, so going over to the diagram here, obviously with this whole length across is 6, so the radius is going to be 3 meters. Okay, so substituting that in, we get something like this. I'm going to simplify this as much as I can, and again, I don't want to use a calculator, okay? So cancelling the 2 and the 4 gives a 2 up the top, 3 and the 3 cubed, cancelling one of those indices out. I've now got 2 multiplied by 3 squared. That's 2 times 9, which is 18 pi. All right, I'm going to leave it like that. I've said this before, but if you were to use a calculator here, and then you're going to use a calculator on V2 and V3, and then you add them all up, you might run into troubles with your rounding because you're going to be, adding together rounded numbers, which might not give you the answer you want. There are ways around it, but my kind of preferred method is just to do it in terms of pi and then add it all together. Another way of doing it, if you wanted to use your calculator to calculate this, you could write it out to say 4 decimal places or something, and do the same with V2 and V3. And then when you add them all to 4 decimal places and eventually round it to 1 decimal place, it's a pretty safe bet that you're going to end up with the right answer. Okay. Anyway, I'm just going to keep doing it in terms of pi. So let's move on to V2. V2 is this part here. Okay, and we're after a volume. Now you probably remember the volume of a cylinder was pi r squared h, because we essentially just treat it like a prism where it's the circular top being multiplied by the depth. Okay, now you might look at this and think, well, we know that the radius is going to be 3. Okay, we've got that. The radius is clearly 3. The height, I didn't give you the height. Well, it's there, but you might need to think a little bit. Okay, if you have a look at the radius above, the radius was 3. Now, I didn't need to draw the radius there. I could have drawn the radius being over here. Okay, that would have also been 3. I could have also drawn it here. That would also be 3. Okay, so if you look at what's actually happening, this distance here is 3 meters, which is going to be the same as this distance here. Okay, so we know that the distance from the top to around here is 8 meters, but we know that this distance from here to here is 3 meters. So we can now establish that the height of the cylinder is going to be the difference between 8 and 3. So that's going to be 5 meters. All right, so we're good to go, I think. We've got pi, r was equal to 3, and h is 5. So 3 squared is 9, 5 times 5 gives me 45 pi. Okay, we're almost there. V3, that's a cone down the bottom. That's going to be 1/3 pi r squared h. So before we sub in, let's just check we've got everything we need. Yep, I'm pretty happy that the radius here, that is in fact 3 meters, so we're good. And the height, which is the perpendicular height of the cone, we do have that, that's 4. So we're ready to substitute in. That's a third pi times 3 squared times 4. And again, I might cancel some indices here. I've got a 3 cancelling with the 3 squared. When the dust settles on that, 3 times 4 gives me 12 pi. Okay, so our total volume is going to be the sum of V1, V2, and V3. And we've worked all of those out. That's 18 pi plus 45 pi plus 12 pi, which is 75 pi, and that was meters cubed. Okay, now I did actually want all of this to 1 decimal place, so let's actually go ahead and type in 75 pi in our calculators now. So 75 pi works out to be 235.619 something or other. And to 1 decimal place, we'll write that as 235.6 meters cubed, correct to 1 decimal place. All right, so this is a good exercise in actually really making sure you're on top of all the different solids we've covered so far. Okay, if you look at this example alone, we use the volume of a sphere, we use the volume of a cylinder, and we use the volume of a cone, all in one problem. Okay, now we also wanted to calculate the surface area of this thing. Okay, so I've done myself a favor and I've made another copy of this diagram down here. Okay, so for part B, we're going to get the surface area. Okay, now there are a few important measurements that we came up with later, and I might just transfer them over to this diagram. Measurements that we came up with before, I should say. So 3 meters was the radius, and remember that this length here worked out to be 5 meters that we got by taking the difference between 3 and 8. Okay, so I'm going to take the same approach as I did earlier in splitting this composite solid up. The hemispherical part I'll call S1, cylindrical part S2, and the conical part S3. All right, so I think we're good to go. S1. Now, the entire sphere would have a surface area of 4 pi r squared, but I only want half of that. Okay, so it's a half of 4 pi r squared. We can see that the radius that we want is 3, so let's go and substitute that in. That's a half times 4 pi times 3 squared. Now, the 2 and the 4 are going to cancel here, leaving a 2. I've now just got 2 times 3 squared, that's 2 times 9, that's going to give me 18 pi. Okay, now S2. Well, S2 is this curved surface around the outside. Now that's part of a cylinder. Now you might remember, I'll just jot it down up the top here. When we covered cylinders, we said that this was the surface area. 2 pi r squared plus 2 pi r h. All right, now if you just memorize that, you're going to struggle, okay? Because you might remember for a cylinder, the 2 pi r squared represents the top and the bottom face. It's 2 lots of pi r squared, all right? 2 pi r h represents the curved surface around, okay? So that's actually the 2 pi r h, that's what we want here. Because you can see in this solid, the circular faces, the top and the bottom, they're not part of the surface area of the solid. So S2 is just going to equal 2 pi r h, and r was equal to 3, h is equal to 5, so we're ready to substitute in. 2 pi times 3 times 5, that's going to equal 2 times 3 times 5 is 30 pi. Okay, I could put meters squared in if I wanted, probably should. And the last one we want is S3. And again, if I were to jot down the formula for the surface area of a cone, you might be able to remember that's pi r squared plus pi r L. Okay, now if I just draw a little cone here, you can probably also remember that, well, memorizing this formula is just no good to you. Okay, you need to know how to use it. Pi r squared represents the top circular face. Pi r L represents the curved surface of the cone. Okay, so in this situation again, that circular face is not part of the solid, so I'm only interested in this pi r L. Okay, so that's the bit that we want. So pi r L. Now going back over to the diagram here, the radius is 3 and the height is 4. So what's L? Well, remember, L is not the height. L represents the slant height of the cone. Okay, so L is this value here. We've still got a little bit of work to do. Okay, so drawing in our 4, we've got a right angled triangle here, and you can see what's going to happen. L squared is 3 squared plus 4 squared, which is 25. So L is going to be 5 meters, and that's the value that we want for our surface area here. Okay, pi r L, where L is the slant height. So substituting in, we've got pi times 3 times 5, which is 15 pi. Very good. So we take a deep breath. We're nearly there. Our 3 components were 18 pi, 30 pi, and 15 pi. And if I want the whole thing, I've now got to add all of these up. So therefore, the total surface area is equal to 18 pi plus 30 pi plus 15 pi. And that's all going to work out to be 63 pi. Okay, wanted it to 1 decimal place. If you type that in your calculator, you get 197.920 something or other. So I'm going to write that as 197.9 meters squared, correct to 1 decimal place. All right, so that's pretty much it. That's a big problem. Okay, there's a lot going on there, and it's very easy to make a mistake. One of these steps across the way. Okay. Also, some little hidden things in there about using the slant height rather than the height. But these are good problems to do. If you can get through them, it generally means you're pretty on top of this topic, right? Because it means you can apply pretty much any solid that I throw at you, the different components, being able to break it apart. Okay, so that's it for this video. Hopefully you have some success with the exercise.